Hello everyone, this is Mr. Cunningham, and today we're going to be doing our last lesson in Chapter 8, which talks about bond polarity. We introduced bond polarity in class, and we talked about how atoms are in this tug of war between each other. And we finished the class by asking who wins this tug of war, or which atom is going to be stronger. And remember that bonds are made of electrons. So the atom that is stronger is going to be the one that holds the electrons from that bond more closely. But how are we supposed to know which atom is going to hold those electrons? Well, we can know that by going back to our periodic table trends. And the trend that we're particularly interested in is something you might remember called electronegativity. And electronegativity is how much an atom attracts electrons to itself. So the higher the electronegativity, the more that atom is attracting electrons to itself. So that's kind of the stronger that atom has a pull on the electrons in a bond. So higher electronegative atoms are up and to the right. So that means that nonmetals have high electronegativities. So they're going to be the ones that attract electrons more than any other elements on the periodic table. So let's look at how we can determine how polar a bond is.
So let's take a look at how we can determine bond polarity. So polarity of a bond is determined by finding the difference between the electronegativities of the atoms involved. So if there's a very small difference between those atoms, then we would call that a nonpolar bond. And that's when those atoms are equally sharing electrons. If there's a medium difference between the electronegativities, then we'd call that a polar covalent bond. And that would be kind of an unequal sharing of electrons. Then if we have a big difference in electronegativity, we would call that an ionic bond, and that would be a transfer of electrons. But what, I guess, is a small difference, what's a medium difference, and what's a large difference? So let's take a look at that scale. When we do and look at the polarity of bonds, we usually use a scale and kind of a spectrum that looks like this. So if you're looking at two atoms, and the difference between them in electronegativity is between 0 and 0.5, we would consider that bond to be nonpolar. If it's between 0.5 and 1.7, we would consider it to be polar, and if that difference is between 1.7 and 3.7, then we consider that bond to be ionic. And we can find the electronegativities of each atom on the back of your periodic table. So let's look at one. Here we have HCl, and up above each atom is listed the electronegativity of each atom. So we have hydrogen with an electronegativity of 2.1 and chlorine with an electronegativity of 3.0. So what we do is we take 3.0 and subtract 2.1, and that gives us a value of 0.9. So because 0.9 falls between 0.5 and 1.7, we would consider the bond between hydrogen and chlorine to be a polar bond. So let's look at another one. Here we have a diatomic molecule, chlorine. So each of these atoms has a high electronegativity. So just because atoms have a high electronegativity doesn't mean that they're going to be polar. Because remember, we're taking the difference. So 3.0 minus 3.0 is 0. So we would actually say that the bond between these atoms is nonpolar. So let's look at one more. Here we have sodium chloride. Sodium has an electronegativity of 0.9, and chlorine has an electronegativity of 3.0. So when we take the difference of those, we find that the difference is 2.1, which is greater than 1.7, which tells us that this bond is ionic. So now let's take a look at a comparison between two molecules. So here we have bromine and hydrogen and chlorine and hydrogen. So these two molecules have a difference of 0.7 for the bromine and hydrogen and 0.9 for the chlorine and hydrogen. So we would say that both of these are polar bonds. However, just because they're both polar bonds doesn't mean that they act the same. We would actually say that the hydrogen and chlorine is more polar than the hydrogen and bromine bond. So these properties are going to be a little different. Because remember, this is kind of like a spectrum. So just because the bonds might fall into the category of polar doesn't mean that they all act the same. So let's look at hydrogen and chlorine again. Now, those little symbols up above the H and the Cl, all that really means is partial positive and partial negative charge. So we've already done the difference in electronegativities for hydrogen and chlorine on previously in the video. And we said that that difference was 3 minus 2.1. So the difference was 0.9. So that means that chlorine is a more electronegative atom, and it's going to want to pull electrons towards it. So the chlorine atom actually has a higher, what we would call, electron density. So really we can say that chlorine's bringing more electrons closer to it, and it is kind of taking on almost a partial negative charge. And if chlorine is taking on a partial negative charge, then that means that hydrogen is taking on a partial positive charge. So if we brought in another HCl molecule, what do you think would happen? If both of these molecules are have a partial negative charge and oppositely charged particles attract each other. So what actually happens is the partial negative charge of another chlorine from the NaHCl molecule is attracted to the partial positive charge of the hydrogen on a molecule close by. So now let's look at how polarity can be affected not only in just one bond, but also in a molecule. So let's look at water, H2O. So these molecules have a partial negative charge around the oxygen because oxygen has a greater electronegativity than hydrogen. So what's actually happening here is oxygen is pulling on those electrons that are shared between each hydrogen and causing it to have a partial negative charge. So we draw this by drawing arrows towards that oxygen, showing that the polarity of that molecule is towards the oxygen. So there's more electrons, there's a higher electron density towards that oxygen atom.
Well, that's going to end our lecture over bond polarity. I'd encourage you, remember to write your questions down so that I can answer them when you come into class tomorrow. I hope that you learned a lot from this video, and I've got a pretty cool demonstration planned for you tomorrow to help you show molecules and bonds can be polar.